Good evening, everyone, and welcome, and thank you for coming. I'm Chris Stover at the Canadian Centre for Ethics in Public Affairs, or CCEPA, which is a joint initiative of the Atlantic School of Theology and St. Mary's University in Halifax. I'd like to welcome you here tonight and thank you for taking the time to come out and participate with us. And on behalf of the CCEPA board and the co-sponsoring institutions, who are York University, the University of Toronto, and the SSHRC-funded National Cluster for the Humanities and Social Studies of Science, or the Situating Science Knowledge Cluster. Tonight's presentation is part 3 of a 5-part national series entitled Trust in the New Sciences, Remaking the Human. It's organized jointly by CCEPA and the Situating Science Knowledge Cluster, and greatly supported by the local node director at York University, Bernie Lightman, and by Anjan Chakravarti at the Institute for History and Philosophy of Science and Technology program here at the University of Toronto. So I'd like to acknowledge their efforts before we get underway. Because tonight's lecture is part 3 of a 5-part series, it doesn't mean you've missed anything by not hearing parts 1 and 2, which took place in Halifax and then Vancouver, and parts 4 and 5, which will go forward in Montreal and Edmonton in March. There's an overarching theme, but its separate parts aren't chronologically related. So if you're interested in knowing about the other parts, you can go to the CCEPA website or the Situating Science website and watch those DVDs or download them. So please have a look at those websites if you're interested. So before we get to the nuts and bolts of tonight's presentation, just a few things. There'll be a Q&A session after our guest speaker. And there are 2 aisle mics set up for you to do that. They're actually quite close here down to the podium. They may be moved back up at that time. Because this is a DVD recording for later, your questions would be really great if everyone could hear them. So if you'd use the mics, that would be great. The other thing is either in your hand or on the chair next to you, you might see an evaluation form. Your feedback is really important to us to find out how we do these things, what we do right and what we don't, and to move that forward to our next presentation. So if you could take the time to fill that out, it's hugely appreciated. So now, please help me in creating a warm welcome for Anjan.
Thanks a lot, Chris. As Chris mentioned, I am Anjan Chakravarti. I'm the director of the Institute for the History and Philosophy of Science and Technology here at the University of Toronto. We are absolutely delighted to be collaborating with a bunch of people who are just a pleasure to work with. Our colleagues at York University, the Canadian Centre for Ethics in Public Affairs, and the Situating Science Cluster for the Humanities, for the Humanistic and Social Studies of Science. Wonderful group of people. It's been wonderful working with them. I'm even more delighted at this very moment, of course, to be introducing Professor Colin Milburn from the University of California, Davis. Professor Milburn has the sort of background that we highly prize in our field, a combination of humanities and sciences. He has a BA, an BS, and an MA from Stanford University, as well as a PhD from Harvard University. His research explores a tantalizing nexus between issues of literature, science, and technology. He's published widely on the history of science and on modern technologies, and in particular, of course, on the nature of nanotechnology, with his 2008 book, Nanovision, Engineering the Future, which was published by Duke University Press. And I understand from a very reliable source that there is another book in the works, almost completed, called Mondo Nano, Fun and Games in the World of Digital Matter. So keep your eyes peeled for that. Going by what's reported about nanotechnology in various media, it's more than a little bit difficult, I think, to assess its promise overall. On the one hand, I'm sure many people here in this theater tonight have read about how advances in our abilities to manipulate matter at the nanoscale will inevitably yield a utopian conquest of all manner of contemporary challenges in microscopy, in electronics, in medicine, and so on. On the other hand, there's no shortage of fearful paranoia about what evils these technologies may be enjoined to serve, or about their unintended consequences, such as environmental infection by nanomaterials. Professor Milburn's book, the first one, offers a lovely path through this apparent conflict. with an insightful study of the cultural implications of this science, with its fascinating history and rapidly developing present. And so, it's a great pleasure for us to have him here tonight with us this evening to deliver a lecture entitled Nanomorphosis, the Future of the Body in the Age of Nanotechnology. Professor Milburn.
Thank you for that lovely introduction, Anjan, and thanks everyone for coming out tonight. And it's going to be my pleasure to speak to you about nanomorphosis. In 1996, Scientific American magazine published an article called Trends in Nanotechnology, Waiting for Breakthroughs by the science writer Gary Stix. This article focused on the intense hype associated with the field of nanotechnology in the 1990s and the extent to which the promises then being made by advocates of the field were likely centuries away from fulfillment, if not outright impossible. The article introduced perhaps the most famous proponent of this newly emerging science as K. Eric Drexler, the avatar of nanotechnology. The avatar of nanotechnology. When I first read this description, I wondered if it might be an uncanny pun. To be sure, it would seem to refer specifically to Drexler's role at the time as a popular figurehead for the emerging field of nano, the degree to which his name had come to symbolize the wild concepts and promises of a futuristic molecular revolution. Drexler's book, Engines of Creation, published in 1986, not only gave the word nanotechnology its peculiar association with radical and imminent technological upheaval, but it also shaped many people's sense of the wonderful world that might be possible once we learn how to engineer at the nanoscale, at the level of individual atoms and molecules. Yet at the same time, the designation of Drexler as avatar of nanotechnology echoes some of the speculative notions that Drexler had long been disseminating about his own body, all of our bodies, as literal avatars of nanotechnology. For example, in a 1996 conference address, Drexler told his audience, "If you want to know what molecular nanotechnology is, look yourself in the mirror." This idea that we might see our mirrored image, our avatar in the looking glass, as a figure for nanotechnology stems from Drexler's argument that biological organisms, which is to say the very existence of biological organisms, would indicate the feasibility of atom-by-atom molecular engineering. Inside every cell, he claimed, are legions of natural nanomachines, ribosomes, mitochondria, and so forth, that have evolved to do exactly what human beings now hope to achieve artificially, artfully, through nanoscience. Drawing on the theoretical biology of Graham Cairns-Smith and Richard Dawkins, Drexler argued in the early chapters of Engines of Creation that life on Earth itself arose from self-replicating nanomachines, prebiotic molecular replicators in the form of silicate crystals of clay. This eventually led to nucleic acids organizing the replication process, a so-called genetic takeover of non-genetic replicators, then onto cellular structures, acquiring genomes, sequestering them inside of membranes, and then on to multicellular organisms. So for Drexler, each organism would seem to be the incarnation of ancient engines of creation, ancestral machines stretching back across evolutionary history and reincarnated in various copies or mutations inside all living beings. In this way, do we all become the avatars of nanotechnology, or indeed, nanomorphs? The term nanomorph was coined in 1995 by the science fiction writer David Pulver. It first appears in the context of a game, namely the GURPS Robots rulebook for the popular GURPS role-playing system. Pulver here writes that nanomorphs are to be understood as the culmination of industrial nanotechnology. It's a fictional concept here, for they are, quote, robots composed entirely of advanced molecular machinery. In the GURPS game, nanomorphs are powerful enemies, but it is also possible for a player to take a nanomorph as avatar, to actually play a nanomorph in the game campaign. This playability of nanomorphs reflects the same logic of the avatar that has also shaped the language of real-life nanotechnology. After all, to the extent that nanomorph, understood as a robotic swarm of self-organizing molecular machines, to the extent that this describes exactly what Drexler imagined as the condition of any organism, this rhetoric of nanotechnology compels us all to play nanomorph, to wear the mask of nanomorph every time we look in the mirror. The Drexlerian idea of the organism as always already nanomorph owes to Richard Dawkins' notorious account in the first edition of The Selfish Gene, published in 1976, of the body as robotic puppet, a vehicle piloted by the selfish genes inside. Quote, they, the genes, swarm in huge colonies, safe inside giant lumbering robots, sealed off from the outside world, communicating with it by tortuous and indirect routes, manipulating it by remote control. They're in you and me. They created us, body and mind, and their preservation is the ultimate rationale for our existence. They go by the name of genes, and we are their survival machines. The venerable language of creation myths, they created us, body and mind, lurks inside this notion of the organism as an avatar of molecular replicators, a survival machine for the nanoscale pilots who manipulate it by remote control, operating the body via telepresence. The theological dimensions of this and other just so stories about the body as a molecularly engineered machine were already brought to light as early as 1947, here in a science fiction text by Eric Frank Russell called Hobbyist. In this fable, a human space explorer crash lands on an alien planet where he discovers an immense workshop. Here, a powerful alien creature builds organisms from the bottom up, assembling discrete atoms into living beings. It appears that the alien hobbyist running this workshop may very well be the creator god of all life in the cosmos. We learn at the end of this story that the alien hobbyist had long ago seeded the planet Earth with nano-assembled organisms, and that the origin of human life also rests in a primordial act of nanotechnological engineering. Russell's story, one of the earliest fictional anticipations of what we now often call nanotechnology, nicely captures the mythic force of the notion that life itself embodies the principles of nanotech, which is to say, the possibility that we are all robotic nanomorphs. So let us consider this possibility that we are all robotic nanomorphs, that we are all already avatars of nanotechnology. It has become a prevalent figure of speech, a favored idiom among many nanoscientists. The body as incarnation of nanotechnology. Whose body? Well, any body, any organism whatsoever. For example, the nanoscientist Richard Jones has concurred that the organism is proof of concept for advanced nanotechnology, that the very existence of the amazing contrivances of cell biology shows that radical nanotechnology must be possible. Cell biology shows that it is possible to make sophisticated molecular machines that can operate, in some cases, with atomic precision and self-replicate. Or, as the nanoscientist Howard Berg recently said in a technical research publication, E. coli is a remarkable nanomachine. It is a self-replicating autonomous robot. Or, as the chemist Eric Baker said in a nanotechnology conference in Perth, Australia, just a couple of weeks ago, we are all nanomachines. Very complex, very elegant nanomachines. So I wouldn't be too worried about us accidentally developing dangerous nanotechnologies. We are already very dangerous nanomachines ourselves. This notion of the body as nanotechnological, the body as instrument of nanotechnology, the body as avatar of nanotechnology, as nanomorph, I'd like to go ahead and specify this set of notions as nanomorphosis. The shaping of the body in the image of nanotechnology, the production of the body in imaginary connection with the nanoscale world, the direct accommodation of the scale of the body to the scale of its component atoms and molecules. To be sure, the idea of nanomorphosis as transformation of the body in the age of nanotechnology has been quite prevalent in popular science fiction media from the past 3 decades. But I want to emphasize that nanomorphosis is not relegated exclusively to the domain of science fiction, even though it may be a deeply science fictional idea. As we've already seen, the professional discourse of nanoscience often adopts this same metaphor of the nanomorph. And some researchers even seem to desire a future in which the body has become fully nanomorphic through advances in nanoscience, in which the natural nanomachines of the body might be linked with artificial nanomachines to unpack the body from its evolved form and open it to new possibilities. Imagining that the human body might be repackaged in new forms through the work of radical nanotechnology, the nanoscientist J. Storrs Hall once said, "What I want to be when I grow up is a cloud." And of course, science fiction writers have latched onto Hall's claim. Here's an image from the comic book Transmetropolitan, written by Warren Ellis, that features the nanomorphic body as an unpacked cloud of interdependent yet independent nanomachines. It's the pink figure there is the nano cloud. As the cloud says in the lower right panel of this image, it's not magic, it's human tools. So nanomorphosis seems to be as much a concept from science fiction as from science, as much a metaphor as a technical claim, as much about the imaginary far future as about the real evolutionary past. Of course, it's no surprise to see the body reimagined in the context of a new science. In the age of clockwork, the organism was imagined according to the language of mechanical clocks. In the age of the steam engine and thermodynamics, the body was reimagined according to the language of energy and engines. In the age of cybernetics, the body was reimagined as an informational feedback system, and so forth. Norbert Wiener, the so-called father of cybernetics, actually wrote about this historical tendency to reimagine the body relative to any new scientific paradigm in his famous textbook on cybernetics. And that certainly seems to be going on here in the case of nanotechnology. But I want to suggest that this powerful imagination of nanomorphosis that affects both popular culture and scientific thinking on the future of the body in the age of nanotechnology has little if nothing to do with the technology itself. Nanomorphosis is real, though we might see it as something like science fiction. It has discernible consequences in the world as a way of perceiving the body in relation to atomistic realms of matter. At the same time, I want to show that a particular metaphysical tradition, namely the logic of incarnation across a distance historically associated with avatar, has shaped the contemporary imagination of nanomorphosis. Over its long genealogy of translation from its Hindu origins to the contemporary westernized version of avatar made popular by science fiction literature such as Neil Stephenson's novel Snow Crash, or online spaces like Second Life, and of course James Cameron's recent film Avatar, the concept of avatar fundamentally entails the notion of nanomorphosis. Far from being an experience dependent upon advancement in the technologies of nanoscience, nanomorphosis as a subjective transformation of perception, an apperception of the body as instrument of molecular engineering, is a characteristic aspect of the concept of avatar from at least the 19th century onwards, when it migrates into Western culture as a mixture of Eastern and Western metaphysics with a dash of modern science. The tradition of understanding the avatar as a vehicle for the extension of being into another world, and specifically into a lower realm of existence, is of course quite ancient. In Hindu theology, the avatar is divine incarnation, the enfleshment or materialization of a god. It's ultimately all about inhabiting or controlling the substance of matter as such. In Sanskrit, avatara means literally a descent. Ava signifies down, and tar means to cross or to pass over, crossing from one bigger world into another much smaller world, moving downwards to the place at the bottom, which of course is how the physicist Richard Feynman famously opened up our own technological adventures in the nano world with his invitation in 1959 to cross downwards into the, quote, very, very small world of atoms and molecules. Here we would discover, according to the title of his famous speech, There's Plenty of Room at the Bottom, that indeed there is plenty of room at the bottom. This speech has often been taken as the historical origin of the modern field of nanotechnology, and I'll show in a few minutes how the content of his speech intersects with the discourse on avatar. But I just want to note right now this peculiar metaphor of room at the bottom, at the lowest infinitesimal scale of matter. It seems to me that as a metaphysical concept, as much as a technological concept, avatar already presupposes something like becoming molecular, a rendering or incarnation of personal agency at the limits of materiality, at the bottom, or what I've been calling nanomorphosis. Consider this. In the Hindu Vedic narratives, as well as the Puranas, Vishnu usually has 10 avatars. Vishnu's 5th incarnation is the first fully human avatar, Vamana, or the dwarf. So here's a mythical and etymological link between the idea of a human avatar and nanomorphosis, because the prefix nano comes from the Greek nanos, or dwarf. To become a human avatar is to become dwarfed, in other words, nanomorphic. The first Western translation of the Rig Veda, Friedrich August Rosen's 1830 Latin edition, references the Fabulam de Vishnu Nano Vamana Avatara in a footnote, although this story of Vishnu the dwarf does not actually appear in that text. But even so, already in this early translation of Hindu thought into Western languages and Western culture, the worldly appearance of nano, or the smallest of human forms, is given as a pivotal moment in the story of avatars, in other words, a story of translations. Our cultural rendering of nano is determined by such translational processes. At least one nanoscientist has suggested something more than a translational coincidence going on here, however. Srinivasa Ranganathan at the Indian Institute of Science has been blogging about the way in which modern nanotech seems to embody a godlike avatar power, taking over all other sciences in its aspiration to occupy the world of the very small. He writes, "What is nano? Nano means dwarf in Greek. It is 1/1000th of any unit. While this word itself was not used in 1959, Richard Feynman immortalized this tantalizing concept that we can see the very small and move atoms and assemble them by stating that there is plenty of room at the bottom. Where does Vamana come into this? He is the 5th avatar of Vishnu in the Hindu mythology and is the first human form of the incarnations. Vamana means dwarf. As has been narrated many times, Vamana requests King Bali for as much space as could be discovered by 3 of his footsteps. On being granted his wish, he takes the Viswarupa and occupies all space and earth in the head of the king. It may be fanciful, but appears that nanoscience and nanotechnology are following a similar path of taking all space in science. My own affair with nano began with my doctoral studies at the University of Cambridge in 1962. It was an awesome experience to look at atoms with the field ion microscope and feel godlike in evaporating tungsten atoms at liquid nitrogen temperature. It is bliss to be alive at the dawn of this new age. It can be called the Diamond Age in pursuit of the convention of naming ages of civilization after materials such as stone, bronze, and iron. Diamond stands for carbon, which in its new nano avatars as buckyball, nanotubes, and graphene dazzles us more than diamond. Though somewhat far-fetched, the nanotube hopes to grow like Vamana and reach the heavens as a space elevator. The young scientists of today have the most extraordinary challenges and opportunities in this new age. So, even as a scientist, he playfully puts forward a parallel between nanotech and the mythic human avatar, a shared narrative of dwarfing leading to omnipresence and awesome power over matter. But we can make this fable-like connection even stronger, more concrete. Because if we look at the modern history of avatar as a media technology, it turns out that time and again, avatar is foundationally linked to notions of molecular manipulation, the control of the structure of matter, telepresence in nanoscale worlds, assembling objects with atoms from the bottom up, and so forth. All the familiar tropes that we've come to associate with the field of nanotechnology. The translation of Hindu thought during the 19th century was accelerated by the Theosophical movement, which was in turn largely responsible for broadening popular Western understanding of the so-called Doctrine of the Avatars. The charismatic founder of the Theosophical movement, the Russian expatriate Helena Blavatsky, or as she preferred to call herself, Madame Blavatsky, presented a foundational vision of the avatar that synthesized mythology and physical science, spiritualism, and molecular chemistry. Following many years as a nomad explorer of world cultures, journeying around the globe and accumulating vast stores of knowledge of comparative religion, occultism, philology, philosophy, as well as the texts of modern science, Blavatsky eventually settled in New York City in 1873, where she linked up with the growing spiritualist community there and promoted herself as an exceptionally gifted psychic. In 1875, she co-founded the Theosophical Society, whose tenets she first outlined in Isis Unveiled, a master key to the mysteries of ancient and modern science and theology, published in 1877. Attempting to reconcile all world religions as trace remnants of a deeper and now lost occult knowledge, and then align them with the discoveries of modern science, Blavatsky's articulation of theosophy depended on enumerating and disseminating the doctrine of the avatars. Blavatsky portrayed existing religions as well as the modern sciences as conceptual incarnations, or avatars, of the once and future true knowledge, the so-called secret doctrine. In her massive 2-volume tome, The Secret Doctrine, The Synthesis of Science, Religion, and Philosophy, written in 1888, shortly after the relocation of the Theosophical Society headquarters to India, Blavatsky recounts an occult atomic theory from the mysterious lost treatise, the Book of Dizion, and argues that modern atomic theory is itself only a mask or a manifestation of this esoteric understanding. She dissects the texts of leading chemists and physicists of her day, discussing the etheric vortical atoms of William Thomson, as well as Faraday's notion of atoms as centers of force, in order to demonstrate that, even in the rhetoric of modern science, the atom is, as she says, quote, the most metaphysical object in creation. Blavatsky's interpretations of the texts of Victorian science attempt to expose the metaphysical foundations of modern atomism, in order to argue that, instead of buttressing modern materialistic science, the discourse of atomism instead confirms theosophical belief. She therefore claims atoms and their molecular aggregates as the special experimental objects, not of physics or chemistry, which can neither directly measure nor sense them, she says, but of the occult sciences, which pretend privileged sensory and cognitive access to what she calls the planes of atomic being. In this way, we begin to see how the principal theosophist herself imagined herself as an avatar of what we now call nanotechnology. After all, Madame Blavatsky often presented her own body as an instrument of molecular engineering, a medium for controlling the structure of matter, a device for manipulating molecules, emerging as a unique function of her status as a human avatar. In 1875, during the months just before she wrote Isis Unveiled, Blavatsky found herself possessed by an alien presence. Although she'd often channeled a variety of ghostly visitors in her early occupation as a spirit medium, this possession seemed to be something quite different to her. Quote, "And just about this time, I began to feel a very strange duality. I never lose the consciousness of my personality. What I feel is as if I were keeping silent, and the other one, the lodger who is in me, were speaking with my tongue. I know that I have never been in the places which are described by my other me, but this other one, the second me, does not lie when he tells me about places and things unknown to me, because he has actually seen them and known them well. In the night, when I am alone in my bed, the whole life of number 2 passes before my eyes, and I do not see myself at all, but quite a different person, different in race and feelings. This lodger who is in me, this number 2, was soon discovered by Blavatsky to be a living Hindu man projecting himself into her body from somewhere in the cloud-shrouded Himalayas. Eventually known by the name of Kuthumi, this Hindu man was apparently incarnating himself, remotely extending himself into the Western world through the medium of Blavatsky's flesh. She, in turn, acquired access to his adept mind, inasmuch as he was lodged inside her mind, materializing his mystical learning into her cells. She was, she claimed, his avatar, and he gave her the crucial knowledge she needed to compose her theosophical writings, fostering her esoteric skills and wisdom. Most spectacularly, through his presence, she claimed to have developed telekinetic powers, able to move things without touching them, and even to materialize objects right out of thin air. Blavatsky explained this avatar power as a discrete moving of atoms, taking apart the molecules of her environment and reassembling or precipitating them into everyday objects. Quote, "The profound art is to be able to interrupt at will and again restore the atomic relations in a given substance." At one of her demonstrations, she revealed to her friend Colonel Alcott that she could break off atoms from one structure and use them as the core for another. Quote, "Infinitesimally small particles of the object to be reproduced are detached and become the nucleus around which others are drawn." In her metaphysical theatrics, appearing as the flesh puppet of a distant occult scientist from the Himalayas, Blavatsky therefore imagined herself as the vehicle for a descent to the bottom of materiality, seeming to possess the power to do what physicists such as Richard Feynman did not even speculate on until 1959, the technical ability to arrange atoms the way we want, the very atoms, all the way down. Blavatsky distinguished herself from other contemporary mediums, most of whom, ironically, she considered to be deluded frauds, insofar as she claimed that she was much more than a mere communications device, more than a telegraph to the spirit world, but was instead an instrument of remote access. She not only transmitted messages from another world, but by incarnating masters like Kuthumi and many others who soon joined the crowd inside of her, she also became empowered with a kind of telepresence in the world of molecules, a physical purchase on atomic existence. Theosophy, it turns out, becomes a crucial link in the chain of thought that brings us to modern nanotechnology and the avatar technologies of our contemporary culture. For example, after becoming a theosophist, Thomas Edison, famously dubbed the Wizard of Menlo Park, made several public claims that his body, or any body, ought to be recognized as the molecular avatar of some higher power, a swarm of self-organizing molecular entities orchestrated into human form, in other words, imagining the body as nanomorph. And following this logic, Edison began to contemplate the possibility that he, as an inventive human being, might eventually come to control his swarming avatar body on an atom-by-atom basis. In 1890, Edison said to a reporter for Harper's Magazine, "What a great thing it would be if a man could have all the component atoms of himself under complete control, detachable and adjustable at will. For instance, then I could say to one particular atom in me, call it atom number 4320, go and be part of a rose for a while. All the atoms could be sent off to become parts of different minerals, plants, and other substances. Then, if by just pressing a little push button they could be called together again, they would bring back their experiences while they were parts of those different substances, and I should have the benefit of the knowledge." truly some strange ideas, especially for the 1890s. But if we see here an early prefiguration of J. Store Hall's desire to become a nanotechnological cloud, we also know that this particular vision of the nanomorphic body involves what we might call telepresence, the telepresence of the human will, disintegrating the body into its atomic components, sending them out on reconnaissance missions, and by pushing a button, bringing them back with new knowledge for the hive mind. Indeed, there is a historical relation between such notions of telepresence technologies, the modular extension of the human body into atomistic realms, and the theosophical tradition. It was around 1980 that the MIT roboticist Marvin Minsky developed the term telepresence to describe a high-quality sensation of being there, a sensation enabled by future remote control instruments that will feel and work so much like our own hands that we won't notice any significant difference. We might note in passing that Minsky was also Eric Drexler's PhD advisor. Through telepresence instruments, Minsky wrote, we will project ourselves into any environment alien to humans. The logic of avatar seems everywhere present here. The notion of being able to project personal agency from one world into another, the projection of the self into an alien form, a different body yet indistinguishable from one's own. Minsky suggested telepresence instruments would be mechanical hands, constantly improved until, quote, they feel and work just like our own hands. Minsky gives credit for the term telepresence to his futurist friend Pat Gunkel, but he derives the idea from Robert A. Heinlein's science fiction novella Waldo, originally published in 1942. Quote from Minsky, my first vision of a teleoperator-based economy came from Robert A. Heinlein's 1940 novel, actually 1942, Waldo. The first such instruments were built in 1947. 40 years after writing Waldo, Heinlein helped me sharpen up this paper. So, let's look at Heinlein's story. In Heinlein's story, the disabled genius, Waldo, invents devices that he names Waldos, mechanical extensions of his hands for all sorts of useful tasks, ranging in size from gigantic monster hands to tiny little fairy digits for microscopic manipulations. Waldo becomes aware that there exists a other world right outside of our own, an extra-dimensional space of immense energy that could be the basis of something very like magic. Researching the problem, Waldo learns of a long occult tradition on the topic. Quote, there were frequent references to another world. Sometimes it was called the other world, sometimes the little world. He begins to think of the other world as a very small world indeed. I think of it as about the size and shape of an ostrich egg, but nevertheless a whole universe existing side by side with our own from here to the farthest star. Like any good theosophist, Waldo's speculations on how to access this little world lead him to see confluence between modern science and occult knowledge. Quote, there was the hydraulic engineering of the Egyptian priests. Chemistry itself was derived from alchemy. For that matter, most modern science owed its origins to the magicians. Science had run it through the wringer of two-valued logic and placed the knowledge in a form in which anyone could use it. Waldo began to think of the arcane arts as aborted sciences, abandoned before they had been clarified. To obtain the promised godlike power over matter and energy, Waldo must learn how to extend his own agency outside of himself by merging experimental science with the logic of the avatar. You send your force into this other world. You must reach into the other world and claim it. So he resorts to his Waldos. Deciding to conduct fine surgical experiments on the mammalian nervous system to understand exactly at which material point the mind might touch the other world, Waldo uses his tiniest Waldos to create even tinier ones and sets up an enchained system of teleoperators extending from his own hands down to the cellular level. Waldo discovers the finite point of materiality where the organism intersects the little world beyond. The passageway turns out to be located inside the, quote, synapses between the dendrites. By accessing that little world, Waldo suddenly becomes master of matter and master of his own flesh. If we see here, in this story, something nearly identical to Blavatsky's imagination of the avatar as a portal to atomic structure itself, this is no accident. For the narrative of Waldo's adventure channels several of the theories advanced by Heinlein's friend, John Whiteside Parsons, a rocket scientist who was one of the founders of the Jet Propulsion Laboratory in California, as well as a dedicated practitioner of ritual magic. Parsons had been a theosophist since the 1930s before linking up with Aleister Crowley and turning his Pasadena home into a site for mystical ceremonies. Many of Heinlein's stories from this period, including Magic Inc., Stranger in a Strange Land, and The Puppet Masters feature sustained themes of avatar bodies, remote control of the structure of matter, and the merger of science and magic, which characterized many conversations he had with Parsons and his crowd of occult scientists during the years before Parsons literally blew himself up in a game of magic and chemistry gone horribly wrong. The metaphysics of the telepresence avatar carries through into what eventually became known as the foundational fiat lux of nanotechnology. Again, this is Richard Feynman's 1959 lecture, There's Plenty of Room at the Bottom, where Feynman set out a plan for precision control of the structure of matter. Incredible as it may seem, part of Feynman's vision involved copying Heinlein's idea for the Waldo. Indeed, Feynman was quite familiar with Heinlein's concept, and he proposes it as the principal means for doing work at the bottom of matter. So here is a direct chain linking theosophical theories of the avatar to the discursive foundations of nanotechnology itself. Revisiting his ideas about molecular engineering in a 1983 lecture called Infinitesimal Machinery, Feynman suggests various systems for accessing the small world, including Waldos. He also imagines that we will be able to project ourselves into this small world with ease, becoming molecular through Waldo proxies in order to play games, conduct medical operations, and so forth. So seemingly inspired by the on-screen avatars of video games, Feynman imagines that remote-controlled nanomachines could be used as Tory warriors in mock battles with microorganisms. As we see from Feynman's language, the user of this hypothetical apparatus becomes the miniature avatar. You are fighting the paramecia. Feynman maps this hypothetical dueling game onto an earlier idea from There's Plenty of Room at the Bottom, involving a swallowable surgeon, another Waldo avatar for carrying out molecular surgery inside the body. Feynman writes, so we have the idea of making small devices that would go into the biological system in order to control what to cut and to get into places that we can't ordinarily reach. It doesn't seem impossible to me that you could watch the machine with X-rays or NMR and steer it until it gets where you want. Then you send a signal to start cutting. You watch it and control it from the outside. Whether fighting paramecia or cancer cells, we would use tiny telepresence Waldos as our vehicles to enter a space where our bodies would be otherwise too big to fit. In 1985, Robert Freitas, before becoming the guru of nanomedicine, provided a survey of technological progress towards all varieties of Waldo telepresence. Beginning with Heinlein's narrative in the Waldo novella itself, Freitas' account ends with a dream for, quote, remote-controlled medical mites made feasible by modern micromachinery technology. Some medical mites would be like micro-miniature submarines released in the human body for internal sensing and to perform on-site repairs from within. Eventually, such complete telepresence inside biological tissues, descending toward the molecular level, would even enable the idea, he says, of teleoperating people, controlling them as zombies or meat puppets, representing the complete symbiosis between human avatar and microscopic Waldos. No wonder, then, that by the time nanotechnological instruments like the scanning tunneling microscope had come along, they were pre-scripted according to the metaphor of the Waldo as avatar technology. The scanning tunneling microscope has often been called a Waldo, and as the nanoscientists Don Eigler and Joseph Strosio have written, in some sense, we may use the STM, scanning tunneling microscope, to extend our touch to a realm where our hands are simply too big. Or, here is an image by Gerd Binnig and Heinrich Rohr, the inventors of the scanning tunneling microscope, explaining how it works as equivalent to touching atoms with our own hands. The motif of descent and enfleshment in a small other world, nanomorphosis, is right there in this description of human interface with scientific instrument. Demonstrating a keen sensitivity to this very phenomenon, the Nicolet Instruments Company, now a subsidiary of Thermo Scientific, the largest manufacturer of Fourier transform infrared spectrometers since the 1970s, today produces a line of instruments for analyzing the chemical samples as small as 100 picograms that it dubs the Avatar series. With a knowing wink to the traditions of linking molecular chemistry to psychic research, one of the Nicolet models is even called the Avatar ESP, extrasensory perception. So, I've been wanting to show how our contemporary imagination of nanomorphosis, the becoming nanotechnological of our bodies, my body, any body, does not itself depend on anything specifically nanotechnological. Rather, there's a much older history of metaphysical thought that has informed in advance the desire to render the body nanomorphic, which is not to devalue the aspirations of the nanotechnological imagination today, nor is it at all to claim that the real and important work of nanoscience is somehow entirely fictitious. Far from it. Rather, it's to the point it's to point out the historical and enculturated circumstances in which this imagining of the body in the age of nanotechnology, the molecularized avatar body, takes place. As a final example, I'd like to briefly point to a research field that draws upon some of the early concepts of molecular nanotechnology, the ideas of direct engineering control of the structure of matter, and the perpetuation of the nanomorphic body as an avatar technology, namely the field of claytronics. The Dynamic Physical Rendering project at Carnegie Mellon University and Intel, under the direction of Todd Mowry, Seth Copen-Goldstein, and Jason Campbell, combines modular robotics, systems nanotechnology, and computer science to create the dynamic three-dimensional display of electronic information that they call claytronics. The project is working towards a kind of programmable matter, or programmable clay, that would be made of self-organizing swarms of claytronic atoms, dubbed catoms. These tiny robotic catoms, which will eventually be made from nanodust, we are told, but for now they are somewhat larger, could be programmed to take any shape at the terminal end of a Waldo-like communication system. As Mowry describes it, quote, "When you watch something created by claymation, in animated films, it is a real object and it looks like it's moving itself. That's something like the idea of what we're doing. In our case, the idea is that you can have computation in the clay as though the clay can move itself. The project involves animating clay as a simulacrum of an existing object or being. Quote, "The idea behind claytronics is neither to transport an object's original instance nor to recreate its chemical composition, but rather to create a physical artifact using programmable matter that will eventually be able to mimic the original object's shape, movement, visual appearance, sound, and tactile qualities." Claytronics would seem to enable a synthetic copy of the user to appear at a distance, potentially indistinguishable, at least on the surface, from the original. Goldstein says, "Someday, although they won't have intelligence or behavior that is independent of the original, I'm convinced claytronics will reproduce images of individuals that will have the look and feel of a real person, with a shirt on a claytronic image that appears to ripple in the wind and a hand that feels like real skin extended in greeting. I'll be done when we produce something that can pass a Turing test for appearance," he says. "You won't know if you're shaking hands with me or a claytronics copy of me." Such a simulacrum, your replicated self, called an avatar, would self-assemble out of a pile of catoms, would seem to replicate the mythic structure, not only of avatar and incarnation, but indeed of human creation stories in various traditions, including the Greek myth of Prometheus, as well as Yahweh's creation of man, and other analogous narratives of the divine creation of human form out of clay. Not to overlook, of course, the Golem legend or the Pygmalion story, and so on and so forth. In our contemporary mythographic efforts, which might very well seem to be less concerned with the human than with the post-human, we now imagine projecting or creating versions of ourselves out of claytronic atoms, engineering our own avatars out of nanotechnological systems, rendering matter both programmable and animated so as to host our own personal agency at a distance. We create our own human avatars out of raw matter, becoming the information, the essence, the lodger inside of self-assembling atomic or catomic copies of ourselves. And in so doing, in rendering ourselves in the form of nanotechnological avatars, we once again appear to wear the mask of the modern Prometheus. Thank you.
Thanks a lot, Colin. My name's Bernie Lightman. I'm the director of the graduate program in Science and Technology Studies at York University, and I'm going to help moderate the question session of tonight's program. So if any members of the audience, we hope many of you do have questions, if you want to ask a question, there are mic stands at either end of the stage, just down there. So walk on over to one, and we'll try and do this in an orderly way and make sure everyone who has a question gets a chance to ask it.
I suppose the first question I had is whether that distinction between control exercised at the nanoscale and control exercised at the macro scale is significant. And here's one way in which I think it might be significant. It seems to me that in responses to the idea of nanotechnology, most of the utopian dreams of nanotechnology concern the latter case, in which the macro is controlling what's going on at the nanoscale, and most of the fears concerning nanotechnology concern the idea that the nano will dominate, and that ultimately we are all epiphenomena that will be destroyed by nano things that we cannot control. So I was wondering whether you thought that was the case and what you might think.
Yes, thank you. That you've laid out the situation quite nicely there, and I entirely agree with you. This is the case, and that in fact we do have these two different senses of nanomorphosis operating simultaneously, and they do map on very nicely to the utopian and the dystopian poles of nanotechnological discourse. But I don't think they're entirely separated. In fact, I think they inform each other fundamentally, and by that I mean that the ability to imagine the body as made up of nanotechnological machines is the first step to imagining the ability to control those machines. And so the ability then to design artificial nanomachines that might then be our proxies in that nano world are ways in which then human agency gets projected down into that level. And so this is where we see the connection between the exterior control, human agency operating outside some body or outside the molecular scale, reaching down into a space where we can't reach because our bodies are too big. We need some kind of instrument. So we need a probe microscope, or we need some kind of algorithm that will enable us to control self-replicating nanomachines, et cetera. Various kinds of hypothetical and real technologies have been proposed for doing this kind of thing over the years. So it really does depend upon imagining that there is some kind of control that produces the macro scale as an epiphenomenon. And then where then the aspect of human control or human agency comes in is how does one grasp that control. And so if you have selfish genes or if you have natural nanomachines that produce mass or larger epiphenomena such as the body or the organism, how does one gain access to manipulating those particular natural phenomena? So they really go hand in hand. Now, then the utopian, as you point out, the utopian aspect of nanoscience is saying we are able to successfully capture those control mechanisms. We are able to actually intervene at the level of the natural nanomachine. We are able to intervene at the nanoscale from the outside successfully and able to control matter in the way that we want. We are able to make matter do what we want it to do. We are able to produce nanomorphic bodies, catomic bodies, and so forth in the way that we want them to appear. But then, of course, the other flip side of that is, what if we don't succeed? What if we do something wrong? Or what if actually the natural mechanisms of matter, self-organization, self-assembly, self-replication of hypothetical nanomachines and so forth, various lines along a wide spectrum going from realistic applications all the way to far-fetched science fiction ones, but all generally falling under the possibility, what if we lose control, right? And this is the nightmare scenario that has haunted a lot of nanotechnological discourse, for better or worse. And we have seen these things historically vying side by side since, at least since the early 1980s. And really nanotechnological discourse has been characterized entirely by the interplay of the utopian and the dystopian. But they in some ways, they exist side by side and can't be expunged from one another because they inform each other as simply the flip side of the same condition.
I couldn't help but be struck with the way that Nanomorphous has within it a sense of a world without work. And so all these transformations happen like clouds, that with the work is already happened, right? The nanomachines are always already there. The controls always already there, or the kind of, even the visions of the control are like the push button world, right? You know, the claymation guys who control something with just this kind of slight touch. And so I'm wondering what your thoughts are about this kind of, what's at stake in this version of nanoscience, which we know has tons of money, you know, is trying to get infrastructure, but nonetheless has this kind of imaginary of a world without the labor that goes into making nanoscience. And so I'm wondering about your thoughts about what's at stake there.
Some of these more radical visions for a post-scarcity world or a labor-free world in which we might reimagine or rebuild our bodies with ease, all of that forms just one subsection of the huge and global discourse of nanotechnology today. And indeed, probably a predominant aspect of global nanotechnology discourse has come to critique precisely these more utopian and more radical or far futuristic visions that, however, really did drive social interest in nanotechnology and many of the funding initiatives for a long, long time. The possibility of utopian futures or the ease of engineering at the molecular level, redesigning, enhancing the body, and so forth, these were major drivers of interest. Nevertheless, they've come under intense critique in recent years, and many of them for precisely the reasons you're pointing out, that they ignore fundamental aspects of physics, including things like work in technical definition as well as a broader social sense, or that they don't anticipate the massive efforts or transnational efforts that are required to actually imagining instantiating any of these things, whether they would even possibly be possible or not, and so forth. So my answer to your question is that, yes, I think you're offering a principled critique of what seems to be, in many ways, the under-theorized dreaming aspect of nanotechnology as a futuristic discourse of hope. And in many ways, what we've seen in recent years is a turn away from that and a retrenchment into the near term, into even potential environmental consequences or health hazards of nanoparticles that has now informed a lot of the research endeavors around the world. And nevertheless, it doesn't mean that the utopian visions or the far future visions have stopped. They still are produced constantly, but they're now much more networked in a perhaps more effective way than they had been.
I'm actually pretty thrilled to hear you use the term work from a more physical perspective before. I'm thrilled because that's probably the easiest way that I would disprove any sort of fear of gray goo or really nanorobotics at all. I guess I wanted to ask you, I felt that for a large part, the scientific examples that you're using in your talk, which was totally fascinating, are somewhat fringe and not really representative of what nanoscience is today. I mean, for example, the last example you gave about the CADMs, I can give you, there's a long list of reasons why that's not super reasonable, and I have to question how honest it is of scientists at Carnegie Mellon to be showing people these videos, or Eric Drexler. I mean, it's, in my humble opinion, pretty irresponsible to be showing these images of what nanoscience could possibly resolve or become, and portray that as really the future, or really even tenable. And so I feel that to use that as a metaphor for what human control means on the nanoscale is somewhat being misled, maybe, by French scientists. And I guess it was, throughout your talk, there was a lot of personification and I think very fanciful scientists like to employ at the nanoscale. And in a way, I feel it misunderstands really what our control at the nanoscale means. For example, when we're talking about Feynman talking about it, space at the bottom, he meant, I don't want to speak for Richard Feynman, but he meant literally space. And there is a lot of space. A lot of what we understand as solid materials is empty. And when you talk about Don Eigler rearranging atoms, he means rearranging atoms, and that's it. He doesn't necessarily mean that we're going to have miniature cells or miniature robots.
In principle, I agree with half of what you said. And so I certainly understand what you mean about fringe scientists, and to the point that I mentioned a couple figures who, in the nanoscience community, are not considered core in the discipline. However, at the same time, I also mentioned people like Richard Jones and Eric Baker, who I think many, if not most nanoscientists would agree are actually quite core to the discipline. At the same time, there has been a wide-scale rejection of certain of the nano visionaries that undisputably got interest in public funding of nanoscience going in the 1980s. So even though technically, and in terms of their disciplinary belonging, are arguably, in this sense you're using, fringe, I think to understand nanotechnology as a social phenomenon, and the reason why nanotechnology as a field called nanotechnology exists as an umbrella term that has come to join formerly radically dispersed scientific endeavors, now all seemingly part of a single endeavor, we have to understand the social history of that. And that social history does involve scientists who might be called visionaries or radical in their thought, or even, as you're saying, perhaps irresponsible. But again, to question responsibility, I think we have to then ask, well, what role of responsibility are we attributing to which figures? For example, science fiction writers, do we attribute the same kind of responsibility to the writer of science fiction as we do to the scientist? To the popular science writer, do we attribute that same kind of responsibility? Do we attribute to the futuristic visionary the same kind of responsibility, and so forth? I don't think we do. I think we have different senses of what their responsibilities are, pending their, the effects that they have on a given public discourse. And they each have their roles to play. And so this is why I did want to touch upon a variety of these different actors in order to say that even though many of the ideas are often associated with fringe radical science, at the same time, we see the same kind of language being used by more core scientists. And this gets to the second part of your question, which is, I think, essentially what is the implication of the fact that many very trustworthy, very sensible, very brilliant physicists and chemists, material scientists use language forms, use metaphors that don't seem to really be what they mean. They don't really mean we're going to have hands at the nanoscale. They don't really mean we're going to have robots. They don't really mean that E. coli is a nanomachine. However, I think that they're using the language that is available to them, the set of metaphors that works effectively for them to communicate their ideas, both to their scientific peers and to a larger public. Obviously, in many cases, they know they're using these in a metaphorical sense, but they don't necessarily have a more effective way of speaking about these things. And the way in which the metaphors are used does come to shape, to a certain degree, the way that the concepts are being developed. So I absolutely agree with you that many of these figures are aware that the language they use is not necessarily precise and may, in fact, also be misleading or inaccurate in many cases. And some of the figures that I quoted from would actually come right out and say that, oh, I meant that as a metaphor and so forth. But again, I think we have to take metaphors seriously because we never know what they're going to do. One is not in control of one's own metaphors as much as we would like to be, just like we're not in control of matter as much as we would like to be. So, thank you.
The metaphoricity, the science fiction, the rhetoric, Blavatsky, the avatar, it's all fascinating, fun, but it is mostly in the register of science fiction. As we know from thermodynamics, it's a lot easier to destroy something than to create it.
Yes.
Now, if we look at the facts, there's not that many examples out there for real concrete things that have been created through nanotechnology. One of the few, and this is the point of my question, is a report in the Open Physics Journal of nanothermite in the debris of the World Trade Center, scene of the biggest crime in history, the contents of which were removed rather rapidly. Sulfur and calcium particles and arrays that were not attributable to gypsum in the building materials. Could you talk about what's the ethical responsibility of the anthropologist of science and scientists themselves, and what are the real applications so far as you know, and they're not classified? And also speak specifically, if you can say anything about that particular article.
But in terms of the actual real-world applications of nanotechnology right now, they're innumerable. It's one of the largest growth fields in the technosciences today. It's a global industry. And most of the applications that we see today in the market might not necessarily strike one as somehow related to any of the, as you say, more science fictional versions of the discourse that I've pointed out today. Like, for example, nano silver in socks. Odor, bacteria-killing nano-silver particles have been released in clothing. We have nanofilms on clothing as well that are water-resistant and stain-resistant. We have nanoparticles in sunscreen. We have carbon nanotubes in tennis rackets. Lots and lots of nanomaterials are being developed everywhere. And so in some ways, to go through a list of what are the existing applications of nanotechnology would take a long time. In some ways, I think that a lot of the financing that's driving research into nanotechnology is very much still laden with futurity, to the extent that a lot of the investments in nanomedicine, for example, targeted drug delivery mechanisms, one of the major desires of the nanomedicine field to be able to send very small packets of medication directly to the site in the body that you want it to go to kill specific cancer cells and so forth. Figuring out how to do that, there's lots and lots of people who are researching this in biological as well as non-biological ways. There's lots of progress that's going on in these and related fields. Again, I think we're going to continue to see a lot of advancements towards many of these goals, some of which will ultimately be accomplishable in the ways that they're currently imagined, others of which are not going to be accomplished in the way that they have been historically imagined. We might get something similar to them or completely different. And again, we're likely not to see a return of Blavatsky and the theosophical tradition. And yet, what I wanted to show here was not to say that we take Blavatsky seriously as a visionary that should guide our research into nanotechnology, but rather that historically she was taken seriously by other scientists, by a larger public discourse that did come to inform the chain of events that has led us to where we are today. I think it's an interesting history to pay attention to. It does not dictate in any way where we are going to go in the future. However, it may continue to inform the language that used to describe this thing, and the only way we'll know is by continuing to look at the language and the images that are being produced. So that was sort of a roundabout way of answering your question, but hopefully at least I addressed a few
So
of
we'll
the topics.
take one more question over here.
My question was about you're talking about our reimagining of our sense of selves sort of through the lens of this technology. And I think you mentioned that you wanted to distinguish between nanotechnology or nanomorphosis and cybernetic ideas or digital ideas. And early in your talk, you mentioned Second Life. And I wonder if you could elaborate on this distinction between the digital and the nano. In particular, I know that Sherry Turkle at MIT has done some really interesting work on simulations and how people have come to see themselves, and drawing a little bit on the philosophy or science fiction of Jean Baudrillard, about people seeing it as realer than reality. Some interesting consequences of that have been changes in the way that engineers and architects do their work, or new pathologies being developed like internet addiction. And then to go back to Second Life, I wonder, there seems to be this issue of scale associated with the nano, obviously. And it doesn't seem intuitive to me that Second Life should be seen as small. In particular, it's a unlimited landscape, right? Part of the draw is that there's in principle, infinite number of islands that people can be on. And also it's conceived of, like the internet, as maybe something that's both big and small. It's throughout all of space, throughout the entire planet, and it's part of microprocessors, but yet there's this maybe tension there that I don't see mirrored in this nano understanding. So I was wondering if you could comment on that.
Yes, I can comment on both aspects of your question. The first being the distinction, was I drawing a distinction between the cybernetic and the nanotechnological? And I was drawing a historical distinction, but not an ontological one. And in fact, what I would say is that historically, cybernetics influenced the way that the body was imagined at the period in which it first started to emerge. But that does not mean that it then goes away or does not become linked with the nanotechnological. I think far to the contrary. Nanotechnology is very much engaged in the whole history of computational thought and the history of cybernetic thought, to the point that we have active discourses of convergence between nanotechnology, computer science, cognitive science, biotechnology, and so forth. All the idea that all the sciences are converging at the nanoscale today, such that we wouldn't want to separate cybernetics or computer science from nanotechnology. I've also been very interested in a discourse of digital matter that we see a number of, not certainly at all, but a number of nanoscientists talking about the idea that we might program matter. We saw, for example, in the Catum experiments and that particular discourse, but it goes back a number of decades, the idea that we might be able to program the material world in the same way that we program our computers, our hard drives, and so forth. So I think what we're seeing is actually a retention of earlier ideas of imagining computational or cybernetic feedback networks in the context now of a newly molecularized imagination of the body. So just to clarify that particular issue. And then now, where do we see that? And I think your point of Second Life is excellent, and it actually is, it perfectly illustrates this phenomenon. Because, yes, Second Life does have an enormous range of ways in which we can play with scale, and there's no reason in which we should see that particular space as phenomenologically understood as small. At the same time, there has been a historical tendency to imagine virtual worlds as small places. So for example, little used to be the term in the era of Muds and Moos to describe those spaces. They were little worlds, and one would have little sex in them and so forth, and that kind of discourse of smallness. So I don't know that we actually see that retained in Second Life. However, what we do see retained, or actually newly emergent in Second Life, is a direct engagement with the ideas of, and the rhetoric of molecular engineering in the world of Second Life. Because the design principles in Second Life are based upon what the creators call atomistic engineering principles. All the graphics in Second Life are built up from prims, primitive graphical objects assembled into larger structures. The designers in their publicity materials, in their guides to Second Life, in the wiki and so forth, describe building with prims in Second Life as equivalent to molecular engineering with nanotechnology. And they ask residents to see their avatars in that world as being able to engage with the atoms of Second Life and build it into what it is. So the whole Second Life space is actually imagined as atomistically engineered in the same way that we see these radical visions of atomistically engineered with nanotechnology. And it's no surprise because the creators of Second Life are actually they're drawing directly upon these speculative discourses about nanotechnology and that. And also, for example, the whole phenomenon of gray goo attacks in Second Life, self-replicating code scripts, they're very much invested in the language of radical nanotechnology in that world. So I think that just sort of illustrates, I think, what your point was. So thank you.
Finally, now, I do want to thank those who were responsible for getting this set up. Chris Stover, of course, and the Canadian Centre for Ethics and Public Affairs, the Institute for the History and Philosophy of Science and Technology here at the University of Toronto, the York University Program in Science and Technology Studies, and the SSHRC Cluster Grant Situating Science. And finally, most of all, our thanks to Colin for a superb talk.
Thank you.